Yeah.
Today's discussion is about the difference between mass and weight. And before we talk about the difference in mass and weight in terms of physics, let's just talk in terms of what normal usage of the word mass and weight is. So if I ask somebody like Snehashish, what's your weight? Chances are that he'll answer that his weight is 62 kilograms. If you ask me, well, you seem to have put on a little weight. What happened? I'll say, oh yeah, vacation, little too much food, a little less exercise. I started off with 76.5 kilograms and I ended up with 77.8 kilograms, and that was my increase in weight. And that's how we use the word weight in terms of normal English language usage. But then if I say, isn't your mass also 62 kilograms? You might say, yeah, but is there a difference? Well, normal usage of the language, no, there is no difference. You don't need to worry about it. But in physics, since there are two different terms, mass and weight are distinct terms, so therefore we cannot use it interchangeably in physics. Okay, and therefore it must mean something specific. So what specifically does mass mean, and what is the difference between weight? So first thing is that when you say my weight is 77 kilograms, 78 kilograms, what you are saying is basically your mass. Okay. And what is mass? Mass is just the amount of matter that is contained in a body. Okay, it's a measure of matter in a body. Okay, and you can ask, well, matter, isn't it basically atoms and molecules? Yeah, it is atoms and molecules, but to count the number of atoms and molecules in a body is virtually close to impossible. I mean, it's not virtually impossible, it is impossible. Also because all bodies or all objects keep losing and gaining atoms and molecules, so it's very difficult to give a very specific number in terms of atoms and molecules. But we know that atoms and molecules have a mass, and we know approximately, very close approximately, or rather to a very close approximation, what the mass of an atom is, and different types of atoms, what their masses are. So we have an approximate way of kind of figuring out what is the total amount of mass that is contained in a body. And we can say that if we have X number of atoms and molecules that are contained in a body, then it has a mass that can be written as being equal to 1 kilogram. Okay, so that therefore becomes the mass of some object. Okay, and using that mass of that object, the 1 kilogram object, they actually have a certain alloy metal that used to be kept in the Institute of Weights and Measures in Paris, and that was what was called as the prototype 1 kg.
Also have a meter.
There is also for a meter, but this was the old system. I don't think they use the same way to do it now, but actually they had a very special alloy metal made, which is very stable under certain conditions, and they keep it in a particular place in Paris, in France. Used to, it must still be there, but they don't use that as the prototype 1 kg, and that was kept under specially created conditions. So the temperature variation is not much, humidity variation is not much, and so on. So it's climate controlled. And using that prototype 1 kg, they can make other comparative masses, other 1 kg or fractional mass equivalents. Okay, and using those mass equivalent, I think every country can get one of those from the prototype one thing made, and using that they can create other kinds of weights and measures. Okay, so that belongs to a department of government called the weights and measures. So that is about mass. Now, if that is mass, then what is weight? Okay, any doubts about mass at the moment? Any questions about mass? Have you understood mass well?
Yeah, I have a question, sir.
Yeah.
So we know the approximate mass, weight.
No, mass or weight. Talk about one thing.
We know the approximate
Your dog
weight.
also wants to ask some questions.
We know the approximate weight of one atom, right? So if we know a person's weight,
Not the weight. I was talking about mass.
yeah, I have a weight related question. So if we can find, we know the weight of an atom. So then if
No,
we
but
know the weight of a person,
we haven't. I haven't even discussed what is the weight.
okay.
So when I do that, maybe you can ask this question. Okay.
Sir, I have a question regarding mass.
Okay.
Yes, Shiv.
So like I didn't catch like when did you like point the arrow, the mass arrow to 1 kg? Like what are you talking about?
I'm saying that the approximate mass of atoms and molecules we have figured out, and I was saying that if mass means the amount of matter that is there, okay, amount of matter in a body, how do we measure it? Okay, so you count the number of atoms and molecules that are contained in your body, but that's a task that is impossible to do, right? So then how do we find out the mass? Well, we say that we have a general idea of, if you have a cluster of atoms and molecules, how much is their weight going to be? And we use a certain cluster of atoms and molecules, like, say for example, this prototype that is kept in France, and we say that that prototype is actually 1 kilogram. We give it a name, we call it 1 kilogram. Okay, and then using that 1 kilogram prototype, we can say that, okay, so my weight is approximately 78 times, sorry, my mass is approximately 78 times the mass of that prototype which is kept in Paris. And that would be a good indication of what is the mass that is contained in my body.
Sir,
In terms of the atoms and molecules, because I am made of different molecules as compared to that object. Yes.
so the number on the weighing scale is actually the mass of the person.
The number that showed on the weighing scale, yes, it is the mass of a person. Okay, so you stand on the weighing scale and it says whatever 45 kilograms, that is your mass. Okay, but weight and mass, the way we measure it, are closely related. So I'll come to that. So let me talk about what is weight. Okay, so what is
Sir,
weight?
I know how weight is measured.
So are you going to start recording?
I am recording.
It's already being recorded.
My bad.
Okay, so yeah, so what is weight then? If this is mass, then what is weight? Well, if you bring the weight, if you bring the mass, an object, near or at the surface of the earth, okay, so you are bringing it at or near earth's surface. Oops. Undo surface. Then what happens to it? What will happen to it?
It is opposed by the n force.
It is
Opposed by the normal reaction force.
no. If you keep it on the earth's surface, what is the first thing that happens is that
Gravity.
in terms of its experience, whatever that might mean, the object is going to be attracted towards the center of the earth, correct?
Due to gravity, yes.
Due to gravity. Okay, so we haven't yet explored the concept of gravity, but I'll just give you a general idea. Okay, here is the earth, and can I move it a little bit? Yes, I can. Okay, and on or near the surface of the earth, if you keep an object, that object is going to get attracted towards the center of the earth by a force that is called as gravity. Okay, so you may ask, like, why am I wasting my time saying all these things? Just recalling. Okay, now that force, right, is, first of all, it's a force. So what will it be measured in?
Newtons.
Newtons. All right. How much will the quantity of that force be if every 1 kilogram object is attracted by a force approximately equal to 10 newtons? Okay, this I give it to you simply as a fact. Okay, I'm not giving any reasoning behind it. I will give it to you later when I talk about gravity on a later chapter. But it is discovered, and you can easily experience this, right? The force with which, there is a force with which you are pulled towards the center of the earth, and that force is equal to approximately 10 newtons per kilogram. In reality, of course, this is more like 9.8 newtons per kilogram, but for the ease of calculation, we keep it as 10 newtons per kilogram. Okay, so now if this object were 1 kilogram in mass, what will be the force with which it's pressing down?
10 Newton.
Yep.
How did you find that out?
Because it's written below.
Yeah, because I have given you the value, because 1 kilogram is approximately pulled down with a force of 10 newtons. What if the object's mass were 2 kilograms?
2 into 10.
20 Newton.
20 newtons, right? So I say 1 kg, 10 newton approximately, 2 kg, 20 newtons approximately, 3 kg, 30 newtons approximately, 5 kgs, 50 newtons approximately, right? So what is the way in which you can calculate this if this is given? This is your mass,
Yeah.
and this is your gravitational attraction.
Mhm.
Sorry, I can't quite say that. No, that's not the right way to put it. So you can find out the force, okay, that the object exerts in the downward direction by multiplying its mass with the gravitational pull, and the gravitational pull is 10 newtons per kg. Okay, so this force that you calculate by multiplying the m and the g is nothing but your weight. All right. So in general, class 8 students, most of you are approximately having a mass of about 40 kilograms. Information from past years. Of course, there are people who are heavier, people who are lighter, but I'm saying approximately 40 kilograms. All right.
Average. Kind of.
On average, yeah, 40 kilograms. So an average 8th standard has a mass of 40 kilograms. What is that average person's weight?
40 into 10, which is 400 newtons.
Which is 400 newtons. Absolutely right. So now do you see the difference between mass and weight? Mass is the amount of matter that is contained in your body. Okay, and it's measured in kilograms. Weight is the force with which a gravitational field pulls you towards itself, towards the object. Okay, and that on the surface or near the surface of the earth is about 10 newtons per kilogram. So if you multiply your mass with approximately 10, which is what is called as this g, small g, then you get your weight. Weight is measured in newtons. Any questions?
Yeah. How do you calculate mass?
You cannot
Can I tell?
you cannot calculate mass. Actually, what happens, is that when you try to, oops, okay, I shouldn't have done that. Can I do an
Sir, can I tell how a
It came back. I'm so happy.
Yes.
weighing scale
Yes.
measures?
Thank you.
Wait. I wasn't listening. I was just too happy that I deleted it by mistake and I made it come back. Okay. Yeah. What were you saying? I'll try to answer Ishan's question.
Yeah, sir. So how do you calculate mass?
Okay. Strictly speaking, to find out the mass of an object, you have to count the number of atoms in it. Okay, atoms and molecules. That's a stupid task. Nobody will try to do that because it's going to take forever to find out the number of atoms and
Sir,
molecules that are contained in the body. Yes, who's that interrupting?
sorry.
Yeah, it's okay. Go
I
ahead.
didn't mean to interrupt. I just have a question. Yeah. So, like you said, 1 kg is not weight, but 10 Newton is how you calculate the weight. You can calculate in newtons. Sir, so I don't understand the difference between 10 Newton force and 10 Newton weight. Is it the same thing?
Same thing. In general, you should understand that weight means force.
So we can say mg is a force, right?
Mg is a force.
Yeah.
You must say that mg is a force. Okay, so how to find mass? Well, that's an interesting question. The way I defined it, mass is the amount of matter that is there in the body. So the only way to do is to count the amount of matter that is there in it. And that's impossible task to do. So in general, what we do is that we use weight to find out what is the mass. Okay, if you are near the surface of Earth, okay, then what we can do is we can make you stand on a weighing scale. Not with one leg, both legs.
Yeah.
What is it? Looks like you're wearing some boots or something. Anyway, all right. Okay, so what is going to happen now is that gravity is then going to start pulling you downwards. Okay, if it is pulling you downwards, then you are on a weighing scale which is rigid. The weighing scale is lying on a floor that is rigid. So you are going to get a normal support force which is going to be equal and opposite to mg, right? So the weighing scale, what it does is that it has a set of springs in it, if you like to imagine it like that, some springs there. And those springs are connected to a dial. Oops. Bad dial. Yes. Okay. And those dials has weights that are put up over here, and there is a kanta, a sui kanta, and that thing twists to the new position, and that indicates what is your weight. All you have to do is first keep a 1 kilogram object over there, mark it as 1 kg. Then you can put a 100 kilogram object over in this end, mark it as 100 kg. Okay, and then divide it into 100 equal parts. Right? So that is called calibration. And once you have done that, you can put any object on top of it, and it's going to show what is your mass. But how is it finding your mass? It is using your weight to find out your mass. Will this work in outer space? If you are not near the surface of the earth, but you are somewhere really far away, out in space.
Mars.
Okay, so you have the stars and so on in the background. You're really out in deep space. Is it possible to find out your mass using the weight? Not like the way you did on Earth. Here it is not possible to do that, because if I put a weighing balance under you, it's going to show nothing, probably nothing.
Yeah.
Okay, so out there in space, this method of measuring mass does not work. Do you have mass when you go out into space? Of course you do, because you are made up of the same amount of atoms and molecules. So your mass is unchanging. But what has happened is that your weight has changed because way out in outer space, there isn't enough gravity for you to find out what is your weight. If you go to the moon, okay, draw something smaller, quarter the size. Okay, if you are out on the moon's surface, okay, moon's gravity is far lesser than Earth's gravity. It's about 1/6 of Earth's gravitational pull, right? So your mass will remain the same. Snehashish will still be 63 kilograms. But if he uses a weighing machine that he took from Earth, he might be very surprised to know that his weight has fallen to something like about 10 kilograms. Because the gravitational pull on the moon is much lesser. So he'll have to use a special weighing balance made for the moon's gravitational pull in order to find out his...
So we are saying mass is relative.
Mass is not relative. Weight is relative.
Yes.
But then, how can we say, like, so to calculate mass, we need to be on Earth's surface, right? Like only Earth's surface.
For most of us, yes, that is true. Yeah, because we want to know what is our mass on Earth.
So mass changes.
No, once you have measured it on Earth and you say that my mass is 75 kilograms, I just reduced it by 3 kilograms. It doesn't matter where I go in the universe. My mass is still going to be 73 kilograms because I am comparing it to a prototype which has a certain number of atoms and molecules, which which has a mass of 1 kilogram. So that doesn't change anywhere I go. But my weight, of course, depends on the gravitational pull that is there around me.
So if someone lives on moon and he calculates his mass over there, and both Earth's weight is same, right? So the mass...
No, he measures his mass there. The mass will be the same whether he measures it on moon or on Earth. It's the...
Oh, but 10 kg is mass, right? It's not weight.
10 kg is his mass.
It's mass.
So shouldn't it be like 100 Newton on moon?
No, it should be 100 Newton on Earth.
No, you are mistaking the example. If Snehashish, let's say he weighs his mass is 60 kilograms. How did he find it out? By standing on a weighing balance on Earth with Earth's gravitational pull. If he goes to the moon where there is much lesser gravitational pull, 1/6, if he took a weighing balance from Earth to do this, the weighing balance is going to show his mass as being 10 kilograms, and that is wrong. His mass is still 60 kilograms. But because the gravitational pull on the moon is lesser, it shows as if his mass is lesser. So what should he do? He should make a new weighing balance that is going to work for moon's gravitational pull. And then that weighing balance, the moon weighing balance, will also show 60 kilograms. Okay, so just a moment. I think that's all we have time for today. I guess others will have to leave now. So we'll stop here and we will take up this discussion in the next